All right, folks, today we're going to talk about our new unit, 7.1, solving systems by graphing. And our essential question is, how can I find the solution to a system of equations by graphing? All right, so you may be wondering to yourself, what is the system of equations? All right, so let's define that. It is where we have two or more equations, but we're only going to have two right now, with the same set of variables, where the solution is the point, and that point is an ordered pair, x, y, where the two lines intersect. All right, so that is what we're trying to find. I'm giving you a system, which essentially is just two equations, and we're seeing where these two lines cross each other or where they intersect. Pretty straightforward process, in my opinion. So this is what it looks like. Example 1. Y equals negative 2x plus 1. Y equals x minus 2. All right, we have two equations. This top equation has a slope of negative 2 over 1 and a y-intercept of 1. The bottom equation has a slope of 1 over 1 with a y-intercept of 0, negative 2. So we need to graph these two equations on the same graph. So we'll take the top one that I already put in red. Over 0, up 1. My y-intercept, my slope is negative 2 over 1, so that's telling me to go down 2 to the right 1. Down 2 to the right 1. So I have my line. Now, we defined a system as, the spot where the two lines intersect. Now, I have these three dots. The line may intersect right here, or it might intersect somewhere else. So I'm going to draw a line that is going to cover the entire graph that I'm given. So just in case if the line intersects up here, I have a spot where I can figure that out. The second equation, 0, negative 2 is my y-intercept. My slope is 1 over 1, meaning up 1 over 1, up 1 over 1. I have my 3 points. I must draw a line, because that's what we're working with. We're working with lines, so I got to draw a line. I can't just have dots. And I can see where these two lines intersect. That is our solution. Right here, that point. And that point is 1, negative 1. So that's the solution to this system specifically. Let's try another one. Y equals 2x minus 4. And then y equals 1/4 x plus 3. The top equation has a slope of 2 over 1 again, and a y-intercept of 0, negative 4. The bottom equation has a slope of 1 over 4 and a y-intercept of 0, 3. So let's graph them on the same graph page, and let's see where they intersect. So let's start with the top one again. 0, negative 4, so over 0, down 4, right here. Following my slope, 2 over 1, so up 2 over 1, up 2 over 1, up 2 over 1. And we'll draw our line through everything because we just don't know where these are going to intersect at. And the bottom one has a y-intercept of 0, 3, so over 0, up 3. And my slope is 1 over 4, so up 1 over 4. 1, 2, 3. Oh, they intersect right there. I have to draw my line, even though I know where exactly they intersect. It's important to draw my line still, just in case you may have made a mistake or something. And that is our solution point, which happens to be in a perfect spot for 4. I can always check. I can always check my work. All right, and I'll show you how you can do that with a third example. So let me say I give you these two equations, this system. Y equals 4x minus 1 and y equals 2x plus 3. And they're saying that 2, 7 is a solution for it. So I'm going to check it. The way I do that is I plug in 2 for x and 7 for y, and I see if it works. I see if the left side balances with the right side. All right, so if I plug 2, 7 into this top one, that turns it into 7 equals 4 times 2 minus 1. 4 times 2 is 8. 8 minus 1 is 7. Does 7 equal 7? Yes, it does. But we have to try it with the other one as well. So that turns into 7 equals 2 times 2 plus 3. 2 times 2 is 4. Plus 3 is 7. Does 7 equal 7? Yes, it does. This is a solution. So that's our introduction to solving systems, and specifically solving systems by graphing. Let me know if you have any questions.